So we have here kinetic energy at x, that sum of it converted to potential energy, and the other sum remains. So if we want to find the mass of the ball, and we know that gravitational potential energy is mgh, we have here h, g is constant, so by knowing how much kinetic energy converted to GBE, we can divide this GBE by 8 times G and find H. So we have here 8 minus 3.5, the remaining kinetic energy at Y, divided by 8.8 times 9.81. The answer certainly relation between power and force is B equal VF. So V equal B over F. Okay, E equals half M and V2 squared, which is 20 squared, minus V1 squared, which is 10 squared. Okay, this is 400, this is 100. So it is 300 over 2, 150 M is E. For the second change from 70 to 80, we have delta KE, which is required, equals half M 70, 80 square minus 70 square. This is 1500. Okay, and M can be replaced by E over 150, so it is half times E over 150 times 1500. This is 10 over 2E, which is 5E. To find the efficiency, we need the useful output power over the input power. Okay, so we have here average output power, and to find the input, we will use energy from 1 kg of coal, which is E, times the mass of coal, okay, divided by time. This is for 1 train. For n trains, we will multiply by n. So it is n times ne over s. This is the input, and the output is here in the numerator b. S will go up, so it is bs over nme. Elastic is not permanently deformed, and elastic is permanently deformed. We have modulus, Young's modulus, to be stress over strain. Stress is force over area. Strain is extension, which is E here, over the original length, which is L. Okay, this can be written like this: F over A, which is I, d squared over 4 times the inverse of this ratio in the denominator, so it is L over E. This 4 will goes up, so it is 4FL over by d squared E. Okay, to find the energy lost by the system as we go to this 4 centimeter below the original position, we have here a decrease in GBE, and this decrease all stored as an elastic energy by this stretch. So elastic energy here is same as delta GBE, which is mass of the object times G times delta H, 0.04, mg is 8, so 8 times 0.04, which is 0.32 joule. This elastic energy stored, some of it will be converted to delta GBE because from this situation to this situation we have an increase of 2 centimeter upward, and if we want to calculate the delta GBE corresponding to this 2 centimeter increase, it will be again the weight mg, which is 8 Newton, because the block hasn't been changed, times delta H, which is 0.02. This gives 0.16 joule. But the other part of the 32 is still elastic, and we can calculate it by the formula half Fx. F here is the weight, which is 8, and x is the extension, which is 2. Okay, so it is 4 times 0.02, which is 0.08 joule, and the difference between this stored energy and the original one is what is lost. Okay, so again we have a decrease in GBE, in elastic energy store, and after that some remain in the elastic energy store, some goes to GBE store, and if we add these two sums and subtract it from the original store, we will get the lost energy. This gives 0.08 joule. Here's the frequency, and we need the wavelengths, simple and frequently repeated question. It will be 9.1 times 10 to minus 7 meter, which is 910 nanometer, and this is infrared. We have the visible from 400 to 700 nanometer. Greater than this is the infrared, and more greater is the microwave and radio wave, but just 210 we in the IR range. Okay, here if it is progressive, P and Q vibrate with delta phi 90. I don't think that it is even a position of thinking here, because you know that this wave can be represented as a circle, so P and Q in this circle certainly will not have any kind of angle that is even closer to 90. So this is refused. Stationary B and Q with phase difference. There is no phase difference between B and Q at all in a stationary wave, or if it is stationary wave. If progressive Q and R vibrate with phase difference 180, Q and R, Q is here. Okay, to get 180, it must be between a position like B and this position, okay? Because the whole wave, if it is progressive, it is 4 parts. This is the first one, the second to here, the third, and the fourth. So we should have 2 quarters to get a 180 phase difference. But as it says, between B and B and R, it is not a 2 complete quarters. Okay, it is 1 quarter and a part of the second, not the whole second. The whole second should be all of this. Okay, so again, this is incorrect, and certainly the answer is D. Let us check. Stationary Q and R vibrate with phase difference 180 between Q and R, and stationary it is one node, so this is really correct. Okay, displacement of a particle on a wave. It is distance in a specified direction from equilibrium, yes. If we looked to the other choice just to revise and make sure, distance in a specified direction by particle per unit time, this is not displacement if it is per unit time. Max distance from equilibrium position, this is amplitude. Product of speed and time, this is distance traveled by the wave, not displacement of particle on a wave. Filter the question, polarization question. We have I1 that transmitted from this first filter to I node, the originally incident, equal to cosine square 60. Cosine 60 is half, square is 1 over 4, so I1 equals I node over 4, and I2 to I1, cosine square, here is 90 with the vertical, and this was 60 with the vertical, so between this line, the transmission axis here and transmission axis there, it will be the difference between 90 and 60, which is 30. Okay, so it is cosine square 30, cosine 30, square root of 3 over 2 squared, it is 3 over 4, and we can simply relate I2 to I node by removing I1 and putting I node over 4 in state. So it is 3 over 16, and this gives we have the formula if node equal fs v over v minus s for moving towards. It will not be certainly x because we are moving away from it, and as we are moving away, frequency decreases and cannot be the highest frequency. So it is only y or z. For y, the speed is increasing, and only at y it is the maximum that will continue for z. So we don't accept y, okay? So it is only z and certainly between y and z. Okay, this is not node, this is not wavelengths, this is not node again, only d. Okay, which is not correct for two waves meet at a point and have different intensities. They have constant phase difference at the point. No, this is correct. Whether this phase difference causes constructive or destructive interference, it will be uh, some phase difference. Same amplitude, as they have different intensities, they cannot have same amplitude. So this is the one that is not correct. Have same frequency, as they are two coherent, so they must have same frequency, same speed as same medium, so they must be same speed. Creating a problem. In here will be 1, so lambda is 1 over 5 times 10 to 5. Okay, it is in meter minus 1, so no conversion, times sine theta. We need to stop here and think about this theta. The question gives distance between first to first order maximum. Okay, so if the grating is here and this is the center, it is between the first maximum up and the first down. This is the 15 centimeter distance. Okay, so if we want to find theta, we simply draw it and find that it is 7.5 centimeter divided by the distance from grating to the screen, which is 33.5. Okay, this gives tan theta. Okay, so if we want theta, we should calculate tan minus 1 for the same ratio. It gives 12.62, and we then substitute this value here. The answer will be okay, which represent a filament. Filament has an increase in resistance as current increases. If we looked for the first one, resistance is the slope, the gradient of this graph, and the slope of all of these lines is obvious that it decreases, okay, till it becomes 0 when completely horizontal. So it cannot be for a filament lamp. We need resistance to increase, not decrease. If we look here, we have these small straight lines that constitute this graph to have an increasing slope. So it is yes. And in this part represent the case where we reverse the battery. Okay, so we have a battery with the lamp like this, and we just reverse it the terminals. We will get the other part of the graph. Okay, and it should be identical to the first part. So although this may seem like that, in the idea that slopes are increasing, but the other part is not similar to the part in the first quadrant here, so we will reject it. And certainly this only true answer is B. Potential difference is energy per charge, not energy per time. This is power, not energy per, sorry, not power per uh, current. Okay, it is not always the case for potential difference, and not the product of IR, because this requires the R to be ohmic resistor, which is also not always the case. So the universal definition is energy per unit charge. Okay, we have resistance of this cuboid to be equal to resistance of cylinder, and both are from the same material, which is the body. So we can drop rho. We know that R generally equals rho L over A. We can drop rho from both sides, and we have here L over A, which is x squared, and on the other side it is L, which is L over 2 over A, which in the case of cylinder uh, pi r squared. Okay, only by r squared because we treat the cylinder as a wire. Okay, and we know that cross section is just by r squared. Okay, we can remove L from both sides. We can make inverse for both sides, and we can rearrange for R, find the roots. Kirchhoff first is for conservation of a charge, and second for energy. Okay. If I1 is 1.5, so current in this branch is 1.5 ampere, and we need to know the current in the second branch, because if we knew it, we will be able to get the total current in the circuit. Okay, because both of them are union here. Okay, so for this in parallel connection, we have same potential on both branch. Okay, and as potential is equal to IR, so we have I1 R equal to I1 prime, let us say, times the resistance, which is 2R. Okay. In other words, as the potential difference is same on both branches, we have inverse relation between the i's. So I1 over I1 dash equal to 2R over R. So it is equal to 2. So I1 dash is equal to I1 over 2, and I1 is 1.5. So I1 dash is 0.75 ampere. If they gathered here, it is 1.5 plus 0.75. So the current in circuit is 2.25 ampere. Okay, this current is the same that enters here at this point and also divide. And again, potential difference is same for the two branches. So current I2 that enters here is inversely let me just name this as I2 dash. So I2 dash over I2 will be 2R over 3R. Okay, and I2 dash would be equal to 2 over 3 I2. Okay, I2 dash and I2, both of them equal to, as we said, 2.25 ampere. Okay, so we will have two equations here. This is one, and this is the second. Okay, we can substitute I2 dash by its value in I2, so make this equation only in I2, and from this we can get the answer of I2. Okay, so it is I2 plus 2 over 3 I2, which gives 5 over 3 I2. Okay, we can simply divide by 5 over 3 for both sides and get the answer. In case that variable resistor is 0 ohm, so it acts like a piece of wire with no voltage drop, and the minimum reading for voltmeter will be 0. So it is A or B. For maximum value of rheostat or variable resistor 4, we will have the total resistance as 10, and the current will be potential 6 over 10, which is 0.6 ampere, and when multiply this current in the value of resistance to find the potential difference or potential drop across, it will be, okay, so sorry, this is 2.4. Okay, which cannot be drawn from the experiment. Most atom is empty. No. Most of mass of atom is concentrated of nucleus. No, this can be drawn. Nucleus contains protons and neutrons. This is the correct answer because we didn't know what exactly inside the nucleus. We just know that there is positive uh, charge concentrated in the nucleus. Okay, so the is also known from the experiment, and only C that wasn't yet known. Okay, for beta decay, we have either neutrons that transform to proton plus electron antineutrino. This is for beta negative decay. For beta positive decay, it is proton to neutron plus positron plus electron neutrino. Okay, which of them that we have up quark change to down? For neutron, it is up, down, down, and for proton, it is up, up, down. So we have down to up, not up to down, so this is not the case. So it is proton transferred to neutron. Oh, be careful here because it is hadron created, that is the neutron, not the proton. The proton is the one that decayed, and the formed beta is positive. Okay, so it is A. Okay, another regular question about the decay. We have here 238 that becomes 226. So the difference here is 12, which when divided by 4 for the change of E1 alpha decay, it gives 3 alphas. But the problem is we have 92, the atomic number, minus 88, okay, gives 4, and for 3 alphas, change in atomic should be 6. So there is an increase of 2, which comes from beta. So it is 3 alphas and 2 betas.